Hello, all my JavaScript friends. This is TheVirtuoid, aka Mike Smith, and this is our factory game. All right, today we're going to take a look at the Transporter UI class. Now, what does the Transporter UI class do? Well, does do. I don't know what the correct English is there. The idea here is that an extractor, which is located right here, and a purifier or a combinator. Let me clear some inventory out so we can get that showing up something, will extract out a piece of ore or some alloy. And somebody's got to be able to move it along the conveyor belts. And that is the responsibility of the transport. So it will be able to take ores from both the extractor and the purifier, produce what it needs to produce, and eventually be able to produce, as you just saw there, eventually be able to produce some alloy out of the combinators. It's also responsible for moving everything along the conveyor belts until they reach a destination, eventually that destination being the nice, pretty, let's clear that out. There we go. The nice, pretty distribution center, which is where we make our moolah. We'll clear that one out too. There we go. So that's the whole idea of the transporter. So let me show you how it works. I have to admit, it was a little harder than I had initially anticipated, but once I got a handle on it, it worked out like a champ. So let's take a look at the code. First thing we're going to take a look at here is the game object. And why? Because the game object is, as we have covered before, I think we covered it before. If we haven't, we're going to cover it next time. Yeah, I think we'll cover it next time. It is an extension of the phaser scene, and the phaser scene needs at least four different methods to override, and I'm only using three in this particular case, and that's the start, the preload, and the I'm sorry, not the start, but the preload, the create, and the update. What's important here is the update. That's the real critical thing here, because this update is called on every single tick within Phaser.js, and it basically gives the control over to my program to say, what do you want to do with it? And if we are within the tick area, we go to the World UI update. Let's go to World UI update. It does its own update. It first of all goes through each and every single building within the system and figures out, do I need to produce an ore? Do I need to produce an alloy, which is what you see here, here, and here. Once it figures that out, it then goes to the transporter to update. And that's the critical part. So let's flip over to the transport class. Now, the transport class, there are really two very important data stores here. Its entire idea here is to be able to take an ore and say, okay, where's this positioned on the screen? And I need to figure out where the X part of the ore is. And then I figure out where its destination is going to be. Now, it's not figuring out a destination based upon the entire path. It's figuring out a destination based upon piece. So, for example, let's go back to our screen here. Basically, let's just take a look at the extractor and the purifier. Once it figures out we've got a new piece of ore, as you can see there, the ore appears within the extractor. It then says, okay, what's my ending here? So for extractors, purifiers, and what are those called? Those are called combinators. For those particular ones, it's always the middle of the building. As you can see here, you can see in both when they produce, which there it goes, just produce something, something happens in the middle of the screen. So the transporter is going to say, first of all right, what's my beginning point? It's either going to be that, or it's going to be the beginning of a conveyor piece, whether it's a curve or straight or whatever. And it's also going to figure out what the ending point is. And then it's going to tell Phaser.js, I need you to move from here to here. And if you're on a curve, as you can see here, it's everything's kind of curving around. Then I want you to do an interpolation on the curve. And that part I did have to talk about, have AI kind of help me out with. That one was a little confusing on the documentation. Now that I figured it out, actually, it's not confusing, but it was to me at the time. So yes, there was a few little pieces where I had to have AI kind of help me out, but that's the way it goes. That's what it's there for. It's a tool. Just don't let it write code for you. Make sure you understand what's going on. But anyway, that's the whole purpose of the transporter, is to say, I've got a piece of ore. Where does it start? Where does it end? Send it on its way. So let's go back over to our code. So what happens is that there's two very important pieces of data stores we have. One's called inactive items. The other one's called in-motion items. You'll see active items there too, but as I was recording this earlier, this is actually take number 3 of this recording, I realized, I really don't need active items anymore. But its code is there, so there we go. Anyway, but the two most important ones are inactive items and in motion items. Those are exactly what it is. Those are exactly what you said. It sounds like they are. When we do the update within the transporter, because remember, World UI called it update down here. So when we do the update, it's going to first be able to activate any items within our particular transport system and then keep other items in motion. What does that mean? Basically, what that means is activate item says that whenever I add an OR to the inventory system here, I need to be able to activate it so to get it on its move. Whenever an extractor, a combinator, or a purifier adds an OR, it always calls this routine here to add that particular OR to the transporter so it knows what to do with itself. And that's where you see the set active image for the ORs, the combinators, and the purifiers. But what happens here is that all that is set within inactive items. That basically says, I've got a data store here that I have now added an OR. On your next tick cycle, you need to do something with it because it's not moving anywhere. And on that next tick cycle, it will do the activate items. And when we go to activate items, this is where you see it will put the items in motion. It will put the inactive items in motion. The keep items in motion, which we saw earlier up here, will keep the in-motion items in motion. So we basically have a collection of inactive items, ones that have not been added to the database yet, and in-motion items, ones that are already on the move. And we just do the motion of the items. And that whole motion of the items thing here is basically, hey, I need to sit there and, move this item, any one of the items that are currently in there, I need to go ahead and move that item and then either move it out of inactive items into active items or move it from in-motion items to active items, depending upon the situation. Like I said, I can refactor all this and not use active items, but that's the way it is. So what happens on the move? That's the really important thing. Now, I need to tell you a little bit about tweening, first of all, because we're going to be getting the tweening information. What is tweening? Let's go back to the screen. And earlier I said that what the transporter does is it figures out the X and Y coordinates of the X and Y of the starting position of the OR, like it does in the extractor here, and the ending one. So in this particular case, the starting is at the middle of the extractor. The ending is right at the end of the extractor, which is pretty much the end of that little green box you see here. For a conveyor piece, you can see where the start and ending is based upon the arrows. Even same thing with the curve, you can see the start and ending piece with the arrows. Even a T intersection and a X intersection, you can see where the starting and ending pieces are. So what the tweening information does, let's go back to the code, is that I'm going to be getting the information of here's going to be my start, here's going to be my end. Phaser.js, I want you within the space of a certain duration to move that piece from this point to this, from the old point to the new point. And that's all I want to do. And that's it. That's really all it is to it. So the first thing I'm going to do is I'm going to get that tween information. And if it comes back saying there is no tween information, I get rid of error. I get rid of everything. When does that happen? Well, in a couple of places. So for instance, when an OR gets to the purified OR, notice it doesn't come out anymore. It comes out now as a square. That means basically it's going to disappear into the purifier. Also, the same thing is that when the ORs get to the, let's clear that out again so we can get some more stuff inside here. There we go. So that when more ORs now get into the distribution center, we know that something has occurred to that we don't need the OR anymore, so we destroy that particular OR. So the first thing we want to do here is we want to say, if we don't have any more tweening information, we have no X and Y axis, then we just move on. So we set the position where we're going to set the position based upon the tweening information, and then we do a configuration. And this is where we pass the information on to Phaser.js, and it contains some very important pieces of information. First of all, duration. How long is that going to last? For an extractor, for a combinator, and for a purifier, that's going to be 500 milliseconds by default. That can actually change based upon that's the actual distance that it moves. So the distance that it moves will be 500 milliseconds always, because a conveyor belt will always be 1,000 milliseconds. You cannot sit there and make the conveyor any quicker. This is the information we're going to pass to the completion routine. This is what our target is, which is the active item. That's the OR, the purified OR, or the extractor. And then finally, the onComplete's the big thing here, because the onComplete basically says, Phaser.js has now moved it on from one position to another. What do we need? What do you want to do with it? Well, this particular idea here is I'm getting it out of active items. And again, like I said earlier, I really don't need this, but there it is. I find out what the next position is because that's what's extremely important. Now that we've moved this along, what is the next thing we're going to encounter? Is it going to encounter a blank space, or is it going to encounter a building, or is it going to encounter a conveyor belt? And then we're going to do certain things based upon that. So, for example, if it is not a conveyor belt, first of all, if it's a distribution center, we're going to basically say, okay, we got it into a distribution center here. We need to first of all send the game event that we got some more cache because we have, cashed in this. We've cashed this all in. If it's a purifier or a combinator, we're going to add the new ore to the we're going to add ore to the inventory because this is a purifier combinator. Produces different ores. It just doesn't pass the old ore, it just produces a different ore. So that's what that section is. And then we always destroy the image because if we are not on a conveyor belt, then the image will always get destroyed. If it's gone into an extractor, or if it's gone into a purifier, or it's gone into a combinator or a distribution center, or it just hits the ground, it's going to die. And so we kill it at that point. That's where it dies. Otherwise, this is what we do for the conveyor belt. We're going to now set that information in. We're going to take that piece of item because we know we have another conveyor belt to go to. So we're going to throw it back into the in motion items, set that item and say, here we go. We got to, just keep moving that item on and on and on. And so all it does is just keeps looping and looping and looping until it hits one of these particular buildings, as long as it's on a conveyor belt. So the key here is let me stop at this particular point in time and get a little bit further on here and go back over what this get tween information is all about. This is really the heart of all of this because we've got to figure out how we want to move this particular ore along. If it's an extractor or purifier combination, there's our default duration of 500 milliseconds. That means we're going to move it at 500 milliseconds. And the reason we do that is that we want the conveyor from one side to the other to always go within 1,000 milliseconds. But since the ores and the alloys start at halfway between on the extractors, the purifiers, and the combinators, we start that in the middle, so we got a 500 duration. The movement is only half the movement size itself. We determine what the starting vector is, what the start and end point is, and then return all of this information. Ending vectors, movements, duration, starts, end, items, all that kind of fun stuff. If it is a conveyor, it's a little bit different on that one. So basically the first thing we want to do is we get a tween starting and ending position direction, or tween starting ending direction vector. A lot of information there, but basically that's the idea is on that particular one is that we need to get the starting and ending point for the conveyor. So let's flip over to that particular code real quick. That's this right here. And the key with this one is that as the ore hits that next conveyor, we need to find out, well, if the conveyor starting direction does not equal the ending direction of the ore, then we know that the conveyor can't move that ore, and we just basically stop it at that point. We say, well, no, this ore just gets lost. It just kind of disappears off the face of the world. So the whole purpose of this entire section here is to be able to take a look at, based upon what type of conveyor belt we have, what the starting and ending positions are going to be, and if that starting position, and most importantly, if that starting position equals the direction vector of the item, then we know we got a good one, and we just go from there. If it doesn't equal, then it dies. But the key here is that we have a starting direction vector and an ending direction vector for that particular conveyor belt. So as we go back down here, we've got that. Once we know we have that, we get the process conveyor tween information, which is another one. That's this section right up here. This is where we set the duration of 1,000 milliseconds, unit size. The idea here is we do a start. Well, actually, right here we do a start and we do an end. So that gives me the start and the end. But the real important thing here is if it is on a curve, and we define a curve for actually four different pieces of information. We define a curve. Let's see if we can bring that up on the screen here. Let me go to the store. Yeah, that worked out perfect. Okay, on the store here, there are four pieces of conveyors that do curve. That's the curve left, which is on the one on the left here, the curve right, which is the one on the right, this particular T section left, and this particular T section right. So for these particular ones there's actually a curve. So if you have, for instance, you got information going into here, then it's going to have to curve this way or that way. If you got a OR coming in here, it curves that way. If you got an OR coming in here, it curves that way. So that's very important to be able to know that whether we have a curve or not. A straight is straight, we don't care. But if we got a curve, we figure out an interpolation data. We send it interpolation data in addition right here to whether it's a curve or not. And that gets very important when we come down to the get tween information, because once we get the tween information and we set the direction vector and return that process data, once it goes into the configuration here for the tween config, to when we actually run the tween, which is right here, we're going to compute what our configuration for the X and Y, because if it's a curve, then we got to tell it we're going to do a Bezier curve on X and Y, which means that we expect this thing to curve. Otherwise, it's going to be a straight, one down to the other, and then we add the tween. At that point, Phaser.js takes care of everything, and the result of all of that is the nice, pretty curves that you see. Well, kind of hard to see right there. Let's just go over here. Is the nice, pretty curves that you see right here. Doesn't that look nice? And also the same thing with a T intersection. Let's clear the inventory so we can get something coming out here. Watch this T intersection once the combinator spits out a piece of OR, which it should do here any second now. There's a certain number of inventory. There it goes. Now watch the curve. Whee! There it goes. So it does the curve both on the T intersections and on the curves themselves. So that part is very, very important. And I have to admit, this took a little bit of time, and getting this interpolation information, that's the only part I did have to ask AI on. But hey, I understand what's going on and I know what's going on, so I rebuilt it to where it works for me. But that's really all there is to the transporter UI. It's actually, once you get a handle on it, it was very simple. It took me a little while to get a handle on it, but once I figured out that the real key here is taking it one piece at a time. Don't try to compute the entire path, because you can always delete conveyor belts. If you compute the entire path to the distribution center and just go it along its way, the user can sit there and delete a conveyor belt, and now you're stuck. You got to recompute. So the idea here is, once I realize I don't have to do that, I just compute it one at a time, and the key here is just figure out, okay, once I'm done moving it, what do I do next? That's what this next position and next world item is all about. So that's all there is to the transporter UI. Next, we'll go and probably do the game object one more time. I think I've already done it, but I want to do it again since I had to do some refactoring a little early on in the month. Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at virtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.